Okay, welcome. We're going to start talking about writing equations from context. The first question says, 3 times as many boys, B, than girls, G, comment on tweets from LeBron James at any given time. Complete the table with possible combinations of girls and boys, and then write an equation that represents all the possible combinations. So let's start with what happens if we have one girl. So if there's one girl, it says 3 times as many boys tweet than girls. So if there's one girl, then 1 times 3 is 3. So there's 3 boys. So if there's 2 girls, 2 times 3, 3 times as many as the girls, so 6 boys. So we can continue the table here. 3 times as many girls, so there are 3 times 3, 9 here, and 4 times 3, 12. Well, what's actually happening? We are adding 3 every time here. So we can write an equation, and what's the slope? 3. So y equals 3x. If there were 0 girls tweeting, 3 times as many boys than girls are tweeting, so 3 times 0 is 0. So it'd be 3x plus 0, or just 3x. Now, that's an acceptable answer. However, typically this is x and this is y, but x is being replaced by the letter G, and y is being replaced by the letter B. So instead of y, I'll write B. Instead of x, it would be G. So boys equals 3 times the amount of girls. So 3 times the amount of boys is girls. All right, B equals 3G. Let's take a look at this next one. There are 4 times as many children, C, as adults at the park. Complete the table with the possible combinations of adults and children. Write an equation that represents all the possible combinations. So if there's 1 adult at the park, how many children are there? 4 times as many children as adults. So there are 4. If there are 2 adults, then there are 8 children. If there are 3 adults, 3 times 4 from the 4 times as many, 12. 4 adults, 4 times 4, 16. Well, what's happening here? Our rate of change is we're adding 4 each time. So it should be y equals 4x. But we're not using x and y, we're using a and c. This is typically x, this is typically y. So y is being replaced by c, x is being replaced by a. Let's make sure that works. If there is 1 adult, how many children are there? 4 times 1 is 4. 1 adult, 4 children. That makes sense. So this is our answer. You try the last one. Pause the video. Try this last one on your own. Okay, hopefully you tried it on your own. There are 5 times as many dogs as cats at the park. Complete the table with the possible combinations of adults and children and write the equation that represents all possible combinations. So we don't have our numbers here. Let's start with 1, and it says there's 5 times as many, so I know this is going to be 5. Which one is more? There are 5 times as many dogs as cats. So dogs would be the more popular one, dogs. And cats would go in this one. So this is C and D. So 2, 3, 4, and I'm increasing by 5 every time. So 10, 15, 20. So my equation would be y equals 5x. But instead of y, we're using D for dogs equals 5 times as many cats. So D equals 5C. the next ones. So these are a new type of problem. It says Macy is going to the movies with friends. She has decided to buy popcorn and candy for the whole group. Popcorn costs $4 and candy costs $2. Write an equation that represents the possible combinations of how many of each she can buy if she has $50 to spend. So let's see. First, what is she going to buy? She's going to buy popcorn and candy. So we're going to have an X and a Y for this one. X, let's have X be our popcorn. And Y will be our candy. So she's going to buy popcorn plus some kind of candy, and her total, she has $50 to spend. We should put money amounts with these. So how much does our popcorn cost? $4. 4 times the amount of popcorn she buys plus candy costs $2. So $2 times however many things of candy she buys. So that is our equation. 4x plus 2y equals 50. Oops. Let me give you a visual of what this means. So you do not have to write this, just follow along. If I wanted to graph this, just give you a visual of what this means. Popcorn is here. Candy would be our y. And I have all these number intervals. I will just kind of give us a little guesstimate here. I'm going to say, first I need to solve this. I either need to put this in slope-intercept form, or I can use that cover-up method where I cover up the y and get rid of it. Maybe it would look like that if I cover it up. And what do I have left after I cover it up? I have 4x equals 50. Divide by 4. So x equals 12.5 popcorns. So our x-intercept is, we'll say it's here, 12.5. So our graph hits here. For our y-intercept, 2y equals 50. Divide by 2. Y equals 25 candies. We'll say way up here is 25. So what's this mean? Well, this dot here is representing she can buy 0 popcorns. If she buys 0 popcorns, then she can buy 25 candies. And then we would connect these. Or she can buy 12.5 popcorns. Is that possible? Probably not. She probably has to buy 12. She could buy 12 popcorns and no candy, right? That's that ordered pair. 12.5 comma 0, and this is 0 comma 25. Or what other combinations could we have? She could buy, somewhere in here, maybe she could buy whatever this is, 4 popcorns and 17 candies. So we can make some sense of this and what are the possible combinations. Anything that's on this line is the possible combination of what she could buy. And that is where this equation is coming into play. We do not have to do all of that writing in black. Our goal is to be able to write this equation that's in blue and make sense of it. So let's try another one. Tom is going to the fair in town and wants to eat lunch. A hot dog costs $4 and a cheeseburger costs $5. Write an equation that represents the possible combinations of how many of each he can buy. All right, so what are our variables? So we're going to have x and y. And I typically just go in order. So x is going to stand for our first thing, hot dogs. And what's the other thing he's going to buy? Cheeseburgers. So y is going to be our cheeseburgers. All right. So let's write that equation. He's going to buy hot dogs plus cheeseburgers. And how much money does he have to spend? His total has to be 18 or less, right? So he can spend a max of 18. And hot dogs cost $4, so 4 should belong with X. Cheeseburgers cost 5. There we go. So if I know that he's going to buy one hot dog is X, so I can plug 1 in for X and figure out how many cheeseburgers he can afford by now solving for Y. So I could say this is 4 plus 5Y equals 18. So this is 14 divided by 5. It's not a whole number. It should be 2.8, I think. Let's check. Yep, 2.8. So he can buy 2 cheeseburgers and come really close to buying that third one. So what does 4 represent? 4 is meaning it's with the X, so it's $4 for one cheeseburger, or one hot dog. All right. 4X would represent $4 times number of hot dogs purchased. And what does X represent? X is attached to the hot dog portion. So X equals hot dogs. So number of hot dogs. Let's try the next one. Kyle is going to the mall and wants to buy some new school clothes. At one store, a new shirt costs $19 and a new pair of jeans costs $42. Write an equation that represents the possible combinations of how many of each he can buy for $100. So going in order, X and Y. Let's have X represent the first thing, so a shirt. And Y is going to represent jeans. All right. So what number should I attach to X? How much a shirt costs? 19 times X plus jeans. Those are $42. 42 times however many jeans he buys, Y, equals 100. Let's go ahead and define. What does 19 represent? Well, 19 is attached to our X because it's $19 for one shirt. 19X, that's $19 for one shirt. And what does X represent? X represents the number of shirts bought. You try this last one. Pause the video. Okay, hopefully you tried it on your own. If not, pause it and try it on your own first. Abby is going to Target and wants to buy some candles and chocolate bars. At Target, the candles cost $10 and the chocolate bars cost $2. Write an equation that represents the possible combinations of how many of each she can buy for $52. So she wants to buy candles, so 10X. So X is going to be candles. Plus, she wants to buy chocolate, 2 times Y, 2 times $2 for a chocolate bar. We don't know how many she's buying though. So Y is going to be chocolate. And her total needs to be, she has $52 to spend. So what is 10 representing? 10 is representing $10 for one candle. 10X would be $10 for, times number of candles purchased. And X would represent number of candles. did make a little mistake here. I don't know why I wrote the same thing for both of these. So hopefully you caught that and you can fix yours. 19x actually represents $19 times number of shirts bought. Alrighty. So again, for each of these, I could create a table and figure out that line, and every whole number ordered pair that's on the line would represent a possible combination of purchases.